A very good evening, everyone. As we know that we are here to discuss the topic that is Angular unit testing, and we have prepared a demo as well as presentation, and we as a group are going to elaborate on it further. So the context that we are going to cover today are the introduction part, that is what is Angular unit testing, available frameworks for testing, recommended frameworks for testing, and the test command flow, life cycle of unit test, demo, and Q&A session. Now I would like to request Samir to elaborate on it further.
Unit test, we start from the unit testing. So unit testing is a software development process in which the smallest testable parts of an application called units are individually and independently scrutinized for proper operation. This testing methodology is done during the development process by the software developers and sometimes QA staff. Unit tests are written using Jasmine and are run to see if individual parts of an application are working correctly. As a result, unit test will either pass or fail depending on it the code is working correctly or has a bug. Angular uses Karma as the test runner for the project unit test. So basically, what we're doing, so we are testing every unit of our code. That's why it is called a unit testing. And we are writing all the test cases in our spec file that is going to be executed, and our the Karma will run the test for execution. So the test individually cases in isolation is there, and we can also simulate all the error conditions. Developer can run these each of the modification of test cases, and this process is very fast and also a flag test. So now moving to the next slide. Yeah. So available framework for the testing. So there are a number of frameworks that are that available for the different web application, front-end web application testing lab for Angular, React, and different applications. So right now we have first we have the Karma, that is a test runner. So Karma is one of the most effective JavaScript command line tool that can be used to spawn web servers. It can not only be configured to run against multiple browsers, but can also be used to load your application source code and execute a suite of tests on the command line. The power of Karma lies in the unmatchable capability to eliminate browser implementation glitches from the code. The second one is Jest. So with the philosophy of providing an integrated zero configuration experience, Jest is largely used for parallelizing test run across the board of maximizing performance. Jest has the innate ability to generate more stable and healthy code bases and is widely used for all JavaScript code testing purposes, including React application as well. So the third one is Mocha. Mocha advocates the simplicity and ease of use in the Node.js environment. In fact, Enzyme JavaScript testing utility used with the Mocha has proved one of the best combination for testing web application written in React.js. The next one is Selenium WebDriver. So Selenium WebDriver testing automation tools for creating end-to-end testing scenario. The power of Selenium WebDriver lies in the ability to control web browsers through program and diversity in terms of its functionality on a range of browser and operating system. So the last one is Jasmine. So largely a behavior-driven development framework for testing JavaScript code. Jasmine works synchronously with Karma, being the go-to testing framework within the Angular documentation. Jasmine is relatively dependency-free and does not require a document object model. Jasmine is loaded with a feature called spy that allows spying on a function and attribute, parameter, and argument can be tracked effectively. So these are the number of framework. Now we will also compare on the next slide that which is the recommended framework for the Angular unit testing. So as we can see, there are Jasmine is the default test framework used with the Angular. It ships with the Angular CLI by default. Karma is a test runner for JavaScript along with Jasmine. Karma is one of the default testing tool for the Angular. So basically, like whenever we set up our Angular project, by default we get the Jasmine and Karma by default in our Angular project, and we don't we don't need to we don't need to import other extra library for supporting for this testing framework. So we can see the comparison that in terms of stacks, it has the highest number of accounts in compared to the Jest and Mocha. Yeah, so we are talking about the recommended frameworks for testing. So yeah, so that we have less dependency, and in terms of performance time, it has the lowest time, and simplicity is less, and documentation and community and settlement configuration is easy to find, because we got it whenever we create our project, so we get all the setup by default, and so it is so there is no extra setup required for our this setup. So now we can move to the next slide. So yeah, we whenever we create our project using the ng generate component, so there will be a spec file there. So this spec file is responsible for writing all the test cases inside it, and to execute all the test cases, we have the ng test command. So the ng test command builds the application in watch mode and launches the karma test runner. So the last line of the blog is the most important. It shows the karma, then three tests that all passed, and Chrome browser also opens and display the test output in the Jasmine HTML reporter. So whenever Angular CLI set up the environment and install all the dependency for Karma and Jasmine, so it's create by default by default all the test cases are executed with the Karma test runner, and we can see this on our screen that Karma is connected, and we can see all the test cases either is passed or failed. We can inspect it on our browser. So yeah, next slide, Manisha. Yeah, so life cycle of unit test, like whenever we hit the command ng test, so we have the by default command in our Angular CLI that whenever we fire that command ng test, so all the test cases that is written in our spec file are going to execute. So like spec file is like the test the spec file, the file should follow the name component spec.ts naming convention and should be located alongside the component's other files. If you use the Angular CLI to create your Angular application, you might have noticed that app component spec.ts file. This file contains unit test for the main app component when running test using the Angular CLI. All unit tests in files with the spec.ts extension will run. To run your test using the Angular CLI, you use the ng test command in your terminal. As a result, Karma will open up the default browser and run all the tests written with add Jasmine and will display the outcome of those tests. So this is the flow. Like whenever we hit the command, all the test cases are run and we can see all the result on our browser screen. So we can see with the diagram that how the life cycle of unit test is start. So firstly, it execute the unit test, then it fix the defects and re-execute the unit test. That is goes for the code review, then check in code into repository, then check out code from repository and make the changes. So this is the whole life cycle whenever we hit the command for the ng test. Now, if we talk about the spec.ts file and how the test cases are written inside the spec file, this on the left side we have the diagram that describe before each and each of its functions. So basically, these are used to write our test cases, like whenever we create any component with ng generate component, a spec file is there. So by default, we get these function described before each and each. So by using it, if we want to test a particular component or a particular function or HTML element, whatever we want to test, we have to just import it in our describe block, and using the blocks of before each and it functionality, we can test each and every test cases in our Angular application. So we use a describe to start our test, and we give the name of the component that we are testing inside it. The before each tells the karma test runner to run the code before every test in the test suite. Inside the before each, we have test bed configure testing module. Test bed does is it set up the configuration and initializes the environment suitable for the test. Configuration testing module sets up the module that allow us to test our component. We can say that it creates a module for our test environment and have declaration imports and provided in it. So just like a ng module in our Angular application, we just import all the component. So this configuration testing module does the same for the testing thing. So we declare the component that we test inside the declaration array. We have to include those of other components if our components if, of interest has a dependency on them. In the provider array, we override the actual service with our spy that we created using Jasmine. Other services that are injected into our component through the constructor and provided directly in this array if we don't want to spy on them. So basically, this is the this is the whole flow that how we create how we import the component, how we import the dependency and write our test cases and fire the ng test command, and the karma test runner start executing. So for the clear understanding of whole flow, Rashmi will demonstrate the unit test cases as well. So yeah, Rashmi.
Okay. Thank you so much, Samir, for the wonderful elaboration. Let's move to the code part. So basically, we have created a utility app. I have served the application already. So this is a basic to-do application, and you can drag and drop also here, like your tasks, and add your tasks, and like this. Similarly, you can edit or delete also. So as we already know that Angular project is made up of templates, components, services, and modules, and they all run inside what's known as Angular environment. So I'm not getting deep dive into how we created the project and services and all. So our basic motive is to know how we written the unit test cases. So for test cases, we have used Karma and Jasmine. So what is Karma? Karma is basically the test driver, and Jasmine is the framework which is used to write the test cases. Okay, and when we create an Angular CLI and application, there is a file called karma config.js. We can see here, right? And whenever we create a component, we get spec.ts file. So this is the file that we use for to write test cases, and it eventually comes with certain piece of code and a certain piece of test cases by itself. Like this is the basic anatomy that is explained by Samir as well, the describe before each and it function, whatever. So let's start with describe. So describe is a test block with the title matching the tested component name. Like this is the main focus of our component, right? App component. And we use an, before each, after describe. So basically, In before each, we are using the testbed.configuration testing module function to create the module environment for testing component. It is as similar as ng module, except that in this case, we are creating a module for testing. And here we have imported router testing module. So what does exactly router testing module is doing? It easily solves the activated route and location dependencies in our test code. The routing testing module also handles the situations where routings are involved. So we have written the basic imports and declarations here in before each, and the compile components. So this is interesting. What exactly it does, it basically converts the templates into a standard templates. As we all know that the browser doesn't understand the Angular and React, right? So the compile component, what it does, it compiles the Angular language into the basic, or we can say standard HTML that can be understood by headless browser. So what exactly the headless browser is? The headless browser is the browser without UI. And here, finally, we have our spec. That is it. So in it function, we can write our test cases. Like we have written that it should create an app. So it comes inbuilt. Like it should create an app in every spec.ts file. We will see the same. Like it should create the app or component or whatever. But apart from that, we can write our own test cases that it should have a title like utility app, or it should render the title. So basically, we have created a fixture here. Fixture is nothing but the object of a class. Like we are creating an instance of the component, because when we will run the our test command, will not be serving the application. We'll run only the test command. So for that, we need to create an instance of the component. So we need to create the fixture of the component, and it expects the output to be true. And what exactly it means? It exactly means that uh, we confirm that the component has been initialized, and if this test passes, that means the component should run properly within the Angular environment. However, if it fails, it's likely the component has certain dependencies which we haven't included in the test configuration. So it is as simple as that. Next is that it should have a title as utility app. So we have created a fixture, basic fixtures and test bed, the instance of our component, and we expect the title to be equal to utility app. And if we'll change the title from utility app to something else, it will definitely throw an error, because this is our statement. We are writing the test case like this. And the third one, it should render the title. So what we are doing here, we are creating a fixture that is the instance object of the component, and fixture.detect changes. So detect changes, what exactly it does, it detects the changes in UI. Suppose if our UI has something like checkbox, and if it is checked or unchecked, for that we use detect changes, like whatever is changed. And then fixture.native element. So it basically what it does, from native element, we can the document object model element can be rendered by the component. So for that we use the native element part, and it expects the app header bar, and its length should be equal to 1. But why it should be equal to 1? Because we have only used app header bar like this. And we can see in the UI, this whole part is the header, utilities, to do widget, and counter widget. So this is the part, and we can see the live example here. Like when we write in document.query selector all app header bar at console, it is supposed to return a node list. So it returned the length equal to 1, right? So this is what exactly our test case is. So let's run the command for test case. That is, I guess, end the test. So whenever we run the ng test command, there is a window of the browser that opens like this, and we can see there are 12 test cases, and whatever I have explained in app component, that it should have a title as utility app, it has passed. It should create the app, it has already been passed, and it should render the title, it has already passed. So let's quickly move to the service. So service is where we write the business logic. So basically we have created a service, and there is a function we are calling in constructor, that is set default task. So whenever our application is initialized, we'll get 2 tasks. Okay, so for that the anatomy is same. We'll start with describe, and we'll create a instance of the service also. Then before each, it will create the module environment for testing. Then it. So it should be created. That first it expects the component service should be created. Then second, it should see 2 tasks when initialized. So whenever we are running our application, at least 2 tasks are initialized. Let me show you this like this. Okay, and yes, and the service fix, and we are calling the function here, and it should the length equal to true, and we are expecting it to be true. Then the next test case is that it should return the current ISO date string for task ID. So the interesting part is that what I'm doing, the ID which I'm taking, when we'll get to this function, I'm taking ID as a current timestamp, just few million seconds here and there, but current timestamps. So we are converting this to the current timestamp, and we are expecting it to be true. So this is our next test case. And the third test case, it should remove a task successfully from the task list. So what we are doing here, we are creating a fixture, and then we are calling our function, and after that we are taking the initial count. Okay, and then we are deleting it by ID. So what we are doing here is we are expecting the final task count to be -1. So if there is 10 tasks, the and then anything is deleted, that should be -1. And the last test case is that it should add a task successfully to the task list. So basically, we are doing the same thing. We are keeping a count, whatever it is, and then we are creating a new task by giving some arguments. These all are strings, and then we are checking the length, and we are simply doing it +1. Whenever we are adding something, we are keeping it as +1. So we are expecting the output to be initial task count +1. And okay, this is the list component. So yeah, this is basic, like before each, and describe before each and it. So we can skip this. The interesting part is this, like we have added some validation, and we have some test cases for validation also. So again, describe is focusing on the current component. The before each creates the test module environment, and the next before each, what we are doing is we are adding some sort of data, like these are some task ID, task title, and we are applying detect changes, like if there is some change in UI or not. And the test cases, it should contain the validation concerns for invalid control values. So what we are doing, we are setting the value, like for edit ID, we have taken the task ID. For edit title, we have taken invalid. Okay. For edit author, we have taken invalid, and edit priority is high. So at component.ts, we can see the edit title. the validators are min length is equal to 4. So what we exactly did here, the next line is expected the object keys, like it is supposed to test in key value pairs. Okay, so we need to have the length to be greater than 0, definitely, and we are supposed to know some sort of value, like the title is min length is 4, and that's why we have what we have given here is 3, which is wrong. So it should display some sort of error, like whenever we edit. Okay. This is validation. Title is required and author is required. So this is how we have created the test case for validation also. Yeah. So basically, these were the number of test cases that were important for us. Like because the component should create, it is already defined by the Angular CLI and spec.ts file. So apart from that, we have written different sort of test cases to test and some validation also. So we can write like this, and we can enhance also, like for services also and all. But the basic motive why we need to write unit test cases. So whenever we are in our daily life or day-to-day life, our new code and new piece of code that we are adding day to day, that should not change the expected output for the known set of input. Because what we are doing here, we are giving some sort of input and expecting some sort of output. So the main motive to write the test cases is this only. So yes, and the next part is code coverage. Okay. So the biggest question is, have we tested enough of our code? On that note, we have tools that generate the code coverage to determine how much of our code is tested. So to generate the report, we need to run a command that is ng test watch false code coverage. So once we hit the command, we also get the overall test coverage statistics. So we can navigate to the folder, coverage folder. Actually, it is created when we hit the command. Then index.html, we can open it in Chrome. So we can see the coverage. However, it's not necessarily important that we can implement 100% of the test coverage. So this is how it is showing the overall test coverage statistics of our code. So we can see the header bar, it is 22%, and to-do list 84%, some are 50%, and this is how it is. So code coverage is nothing but the measurement of the amount of code that is run by unit test cases, either lines, branches, or methods. So basically, we are done with the demo part, and over to you, Samir.
Yeah. So yeah, we have now the advantages for our Angular unit testers. So it has the good documentation and community that enables a smooth learning curve. Jasmine test run on a real browser, unlike Jest, which helps mitigate some of the risk. Migrating from Jasmine to Jest would be easier if required in the future. So the only disadvantage is that unfriendly error logs. So yeah, we can move to the next slide.